Hi, this is Mrs. Often, and we're going to talk today about laws of logarithms. Now, it's very important that you follow these laws of logarithms because they're the law. We have first the product property. Log to the base a of the product u times v can be rewritten as log to the base a of u plus log to the base a of v. The quotient property of logarithms tells us that log to the base a of the quotient u divided by v is equal to log to the base a of u minus log to the base a of v. The power property of logarithms tells us that log to the base a of u to the x power is equal to x times log to the base a of just u. And finally, one that I'm sure you'll all love is the change of base property. This is really useful when you have to calculate like log to the base 3 of 57 or log to the base 4 of 1.275, where the argument is not clearly a power of the base of the logarithm. We can rewrite the expression log to the base a of b as either log b divided by log a, here using common base 10 logarithms, or natural log of b divided by natural log of a. This allows you to use your calculator to do those computations that maybe before you didn't know how to check. For us, we're going to be using these laws of logarithms to expand and condense logarithmic expressions. So our first expression to expand is log of the quantity 5 times x to the third power. So just a reminder, this is 5 times x to the third power. So I don't want to apply the power rule right away. First, I'm going to apply the product rule and rewrite this as log of 5 plus log of x to the third power. Now I can apply the power rule. My first part of the expression, log of 5, will stay the same. In the second part of my expression, the exponent of x will come to the front and multiply the logarithm. So my expression expanded is log of 5 plus 3 times log of x. When you're asked to expand the expression, you do not need to evaluate log of 5, even though you could. You don't have to. Now our other expression in part B is going to take up some more room because there's a lot of stuff going on here. The first thing that I'm going to do is break up this quotient. So I have my numerator and my denominator. So I'm going to have log to the base 3 of 2x to the third power minus log to the base 3 of y squared times z. Next, I'm going to use the product rule just as I did over here. I'm going to put both of the product rule expansions into parentheses, so it's clearer that I'm dealing with the part before the subtraction sign and the part after the subtraction sign. It'll look like this. Here's my first part. And there's my second part. So you can see that I've broken up this product 2x to the third into a sum of logarithms and this product y squared times z into another sum of logarithms. Then finally, I'll apply the power property here and here. Still keep the expressions in parentheses. So I have log to the base 3 of 2 plus 3 times log to the base 3 of x, leaving that in parentheses. And I'm subtracting, in parentheses, 2 times log to the base 3 of y plus log to the base 3 of z. And you can see that this has been fully expanded because there are no products in the arguments of the logs, and nothing is being divided, no quotients, and nothing is being raised to a power. So that's an expansion. Now here we have the forbidden expansion. Never do this. I see this error a lot, that students will say, oh, I have the log of 3 plus k, and I can rewrite it as log 3 plus log k. Logarithms are a function. They don't distribute like multiplication over addition or, even worse, over subtraction. These are wrong to write. And if you don't believe me, please take out your calculator now, pick a value for k, and go ahead and evaluate these. See if they're the same on one side or the other. Maybe, in fact, probably, there will be one value for k that makes this equation true. If you find it, let me know. But in general, it doesn't. So we can't write this expansion. Okay. We also can condense expressions. So I have this expression, it's a big mess. I want to get it into a shorter expression that has a logarithm of just one argument. So first, I'll condense each of these separately. 1/2 log x is log of x to the 1/2 power. You can also write this as square root of x. Plus 2 log y is log of y squared. So now I've eliminated the multiplication of the log by a constant value and put that back into the power. Now I'm going to combine these together. That sum will get combined into a product. So I'll have log of x to the 1/2 power y squared. And I'll just put that expression in parentheses to indicate that that is the entire argument. Over here in part B, I have log of x, not much simplifying I can do there, log of y, again, not much simplifying, and minus 1/3 log z. So this, I'll replace, keep my first two the same. They don't need to be changed around at all. Okay. You can, of course, write cube root of z. It doesn't really matter to me. Z to the 1/3 is just fine. So now I see I'm going to have a product of these two divided by z to the 1/3. And that's my final answer, a logarithm of a single argument. So I have one more condensing problem and then a final question for you guys to think about, and we'll share answers together in class. Here's using the laws to condense logarithms. And you can see that this is a big mess. Since I have logarithmic expressions within parentheses, I'm going to condense these first. So we'll simplify within the parentheses first to get 2 times log 3y minus 1/4 log, this is subtraction, so quotient property, q divided by r. Then I'll apply the power property of logarithms to get my first expression, log 3y squared. Okay, these are both being raised to the second power, minus log q over r to the 1/4 power. Now in the end, this is going to be a hairy mess to look at. This is one of those problems that I kind of regret making up because it is a huge expression, but we're just practicing skills, so I guess it's okay. So I'm going to have log of 3y to the second power divided by the 4th root of, because it's to the 1/4 power, q over r. This looks pretty bad, huh? But this is as bad as it gets with condensing. Now I do want you to think, now that you know about the laws of logarithms, I have 3 functions here. Which 2 of these functions would have a graph that would look the same? And why would this happen? My 3 functions are natural log of x divided by natural log of 3, g of x, natural log of the quantity x divided by 3, and h of x, natural log of x minus natural log of 3. 2 of those graphs are going to look exactly the same, and it's up to you to figure out which ones and why, and we'll talk about it in class. So thanks. That's how you use the laws of logarithms.